Hi guys, welcome to the Tree of Math. Today we'll be looking at an integral, which is the square root of 1 plus cosine of x dx. Now at first it might look a little strange, but you may encounter this when calculating the arc length of a curve in polar coordinates. So at first glance you might want to use trig sub, but that doesn't really apply to this integral because there aren't any other terms to substitute our dx in or our du in for. So we aren't really able to eliminate any terms in our integrand. But what we can do is take a look at our trigonometric identities. So recall that cosine of 2 theta has 3 different forms, first of which is cosine squared of x, cosine squared of theta, minus sine squared of theta. The second, 1 minus 2 sine squared theta. The third, 2 cosine squared theta minus 1. Now, these three are basically all the same. The way you derive all three is through the Pythagorean theorem, which says that the cosine squared theta plus sine squared theta is equal to 1. So you take any one of these forms and then solve for either cosine squared of theta or sine squared of theta in the Pythagorean theorem, and then you substitute the resulting expression back into your cosine double angle identity. So taking a look back at our integral, the square root of 1 plus cosine of x. What we want to do is raise the power of our cosine of x term and get rid of our constant term, right? Taking a look at our double angle identity, we have one form that does exactly that. Takes our cosine of 2 theta to 2 cosine squared of theta, so we just divide whatever angle in cosine by 2 and then raise that power by 1. And then we subtract 1, which also gets rid of our constant. So let's apply this. First, matching the form, we want our cosine of x to be equal to cosine of 2 theta. That means our x over 2 must be theta. So plugging this back into the integral, we have the square root of 1 plus 1 plus 2 cosine squared of x divided by 2, and then minus 1, where this form matches this form right here. And then dx. So we can see that we get rid of our constant term, and our cosine is now a second degree term. So what we have is 2 cosine squared of x over 2, and the square root of that, dx. Of course, this is equal to the square root of 2 times cosine of x over 2, dx. And now this is just a simple matter of u sub or just directly solving the integral if you're comfortable with that. So we have square root of 2 and then times 2 because of the chain rule. And then we have sine of x over 2. And we can't forget a plus c. Simplifying this a bit, you can write it as square root of 8 or 2 root 2 sine of x over 2 plus c. And I strongly encourage you to take the derivative of this and see if it eventually gets you back into our integrand, which is the square root of 1 plus cosine of x. And the thing with integrals is that you can always check your answer after, but that is all from me, and I will see you in the next video. Thank you.